We're going to solve the system of equations using elimination method. Elimination is useful when the two equations are lined up in the same formatting, where you see the x's and y's together on the left side of the equation and the other numbers on the right side of the equal sign. To do elimination, we're going to take these two equations and add them together. If we start to add these, positive 3y and negative 3y makes 0. That cancels out, and that's why it's called elimination. Positive 3 and negative 3, the y's get eliminated from this problem. Now we have 2x plus 5x, 7x, and then negative 2 plus 16, 14. Notice the y's are no longer in our problem. All we need to do is finish solving for x. We're going to divide both sides by 7, and we get x equals 2. Is this your final answer? No. The original problem had both x and y. So we need to go back to the original and finish finding the y. I'm going to pick the top equation. It does not matter which problem you pick. So we'll pick this one, and then we are going to substitute in our answer for x. So the equation said 3y plus 2, but we're going to change that x also to a 2, equals negative 2, and we need to solve for y. So I'll do the calculation. 3y, 2 times 2 makes 4, and finish solving for y. To get the y by itself, minus 4 on both sides. The 4 minus 4 cancels out. Negative 2 and minus 4 is negative 6. Divide by 3, and we get y equals negative 2. This answer with both x and y tells me on a graph where these two lines would have intersected as a point on my graph. You can even write it as a coordinate, 2, negative 2. To check your answer, we can plug our answer into that second equation. So I will pick this bottom one here, and we need to still plug in our answer. So instead of negative 3, we're going to plug in our y, 5, plug in our x, and make sure does that equal 16. So checking my answer, the y we are putting in is negative 2, the x we're putting in is positive 2. Let's see, multiply. Negative 3, negative 2 is 6, plus 5 times 2, 10, and yes, that does make 16, so our answer is good. We will try one more example, and then you can finish the rest on your own. Oh boy, when I move the words, it did not move the page. Let's see here. Here we go, second example. Notice again that the way the problem is lined up, if we try to add these together, the x's or the y's should eliminate. X's are both on the left together, y's are on the left together. We have the equal sign and the numbers on the right. So if we start adding negative 2 plus positive 2, that cancels out to make 0 x's. It's called eliminated. And we're left with the y's. A negative y, you can think of that as a negative 1y, plus 3 would be 2y, and negative 2 plus 10 would be 8. To get the y by itself, divide by 2, and we get y equals 4. We're not finished. We have to go back, pick one of your original equations from the top, and plug in your answer for y and calculate the other part of our answer, the x coordinate. So 2x minus, we're replacing the y with a 4, equals negative 2. Those parentheses are not doing anything there. There's no number to multiply by. Now we're solving for x. Add 4 to start getting the x by itself. We'll keep the 2x. Negative 2 plus 4 is 2. Divide by 2. X equals 1. Now that I know my answer, I can just take a moment to double check it, use the other equation to plug in my answer and make sure I didn't make a mistake. Negative 2x, plug in with our answer of 1, plus 3y, plug in our answer of 4, equals 10. Multiply, negative 2 times 1, and 3 times 4, and yes, that is 10, so our answer is correct. Let's go to the next page for a minute. Notice this problem. When I look at the two equations, if I try to add them together right